of Terraform, DevOps in these internship sessions. So those who have attended a DevOps cycle earlier, so you may find it common, but let us make it fresh for the new people coming and joining us. And with the example that we are going to have a demo as well. So that also will be a bit different from the earlier cycles. Okay, so let us understand Ansible, what it does, why should we be using it, and what is the structure and everything. So let me make it full screen. So I hope the screen is visible, and let us move on to the next slide. So it is like we are going to see the Ansible architecture or the structure. We are going to understand the Ansible components like hosts, inventory, configuration, playbooks, modules. There are variables, of course, like any tool, it will have variables and interpolation. There will be very important roles or a very important feature of Ansible called Ansible roles. And we will implement Ansible roles over Ansible Galaxy. Then there is for the security feature, we have Ansible Vault. And then next day we will have a hands-on. Today I will explain you the hands-on if possible. Otherwise we will do it on the next day. Okay, so we will explain the hands-on what we are going to do, and then we will actually demonstrate the particular thing. What and why Ansible, history of Ansible, how Ansible works, and Ansible architecture. So Ansible, we have learned in Terraform. So what happens is you have Terraform. You know, we have learned about Terraform, how it does work on a cloud. On a cloud, you provision. So you basically provision or create the resources, cloud resources. But that is not enough, because once you have created the physical form of the various devices, various storage, various users, and so many things you can create. So that needs to be configured. So for that configuration, we will need something else. Terraform cannot do that. So we will need Ansible, another tool of DevOps, which will work on these resources, created resources or managed resources. And then on top of it, it will configure it to make these resources usable for the end users, because there will be users who are going to use those resources. Okay, so these are users who are going to access your application over the resources. And therefore, those applications or those environments have to be configured, and so many things have to be done. For that, we have a master tool called Ansible. Any question? So Ansible is an automation. Why do we do Ansible? Because mostly, again, Terraform, Ansible in turn will work as automation tools within the CI/CD pipeline. So everything, our intention is to create a project of DevOps project with our microservices being deployed, automatically monitored, automatically deployed automatically, okay, and then maintained, managed automatically. Everything has to be automated so that there is minimal human intervention. And not only so we have installed a software, but will we do it manually? Let's say there are around 50 systems spread all over the world for a particular organization, because our organization is not local, it is global. So global means it can have their branch offices any part of the world. Now, so your head office is somewhere in US. So your main office is in US, and you have your operations spread over India, Japan, and some country in Africa. And there are several installations or several, and that is also you have used Terraform to configure or not configure, to provision the systems over India. Let's say the entire development team is hosted in India. Japan has the management team. So the people working there will have the servers and all the systems installed, quality systems installed over here, where this management team will be working over in the Japan office. Development will be taken care. So the entire environment for the development will be provisioned from one place, from US head office. This is the head office. Okay. And in Africa, there is a very important configuration or the team called quality assurance and testing. So something which is developed over for this US organization, developed in India, managed. So all the resources that are developed are managed from Japan, and the testing, so the development will come through the Japan team. They will deploy it over to Africa, because these servers are meant for the high-end servers. They are meant and deployed basically with the objective in mind to test, to make the quality assurance. So to check whether the quality of the development or the product that has been developed is the best one. And it has to test it end to end so that there are no gaps in the requirement. But all these things have been provisioned from one place through Terraform. And now you are configuring them with Ansible, but from one place. So there are, let's say, there are 20 servers, development servers, pre-production servers, or maybe the pre-production servers are over here. Or the UATs, pre-production servers. And here also you have the testing servers. And the production servers, production server. Or the pre-production servers can also be over here. And there are, say, management servers over there, so that all which you develop here, that can be managed and configured over in this. And thereafter it will be deployed to the testing servers. And if everything goes fine, then it will be deployed to the pre-production server for UAT. And thereafter it will be production. So everything has to be, the environment has to be set up. And who will do the setup of the environment on the physical servers? It is Ansible as a configuration management tool. And everything is being done over a CI/CD pipeline. We will come to that learning after few weeks. Okay, so we will learn basically the Azure DevOps CI/CD pipelines. This is another fantastic tool over which we will deploy Terraform, Ansible, and other tools. So they will work as an automation for the automation of the entire process. So Ansible is an automation and orchestration tool. Why orchestration tool? Because from one place, you do not need to go physically in India, Japan, and Africa to configure or manage those systems. You sit in your head office or somewhere in US and do all this work over in different the separate distributed systems. So that's why it is called orchestration tool. Very, very popular for its simplicity of installation, ease of use in what concerns the connectivity. So the main issue will become the connectivity, because these are not hosted locally. They are distributed all over the world. So you need a very good infrastructure of your network and connectivity to the client. So that will be managed with the help of Ansible, the connectivity. It's lack of agent. So that is one important thing. When I'm discussing Ansible, there is a competitor called Chef. How many of you have heard the tool called Chef? Anyone? So Chef is also one configuration management tool, but this is coming from a different house. It is a competitor to Ansible, but Chef is not simple. If I take generally in my main course, I take 5 sessions of 2.5 hours to complete Ansible. So the learning curve is quite simple. With these 5 sessions, the theory is only 20%, and the rest 80% is hands-on. I will complete the entire in-depth knowledge of Ansible and learning of Ansible. Whereas if I had to somehow have to teach Chef, it will not take, it cannot even, I cannot complete the 5 sessions with the installations and few things. So it will take between 10 to 12 sessions. And that too, we cannot cover the entire thing of Chef. Whereas just in 5 sessions, I can go into the depth and learn much more features than what I can do in Chef. Because Chef is not user friendly. As a tool, it takes a lot of your practice, lot of your knowledge, lot of your time and skill to understand Chef, the working of Chef. It is not simple. The simplicity is entirely in, and that's why Ansible is popular. See, something like, why is English so popular over other languages? Most of the people will understand, or at least if not speak, can understand a bit of English. Why? Because it is very, very popular. Why it is popular? Because English is one of the simplest language to learn. It is not difficult like Chinese or maybe any other language, Spanish, French, Hebrew. Okay, so this becomes the hallmark of popularity. Why it is so popular? Simply think, same is applicable for Ansible. Because all the features that is inbuilt within the Ansible can be easily understood because of its simplicity of use. Any questions? And the one of the most important things what I was saying of the agent. Agent, Ansible is agentless. What is agent? For this, see, you are working on a place and one single place, but you are actually working with different interfaces all over the spread all over the world, or different resources spread all over the world. So your connectivity and all these things are very, very important. What Chef does, Chef is a pull based model, Chef. Whereas Ansible is push based model. The advantage of push based model is that you on the master server in one place, you know what you need to do. So you just have a one-way communication between your resources spread over all over the world, because you can push all your requirements over there. Whereas in Chef, you have to install the agents in each of the servers that needs to interact with the Chef on the master master Chef, I'm saying, but it is actually the master server where Chef is installed. So there is a pull mechanism. You pull. So there must be some agents installed and running every 24/7 on each of these servers. So see, these servers are very important servers. If you keep your agents working 24/7, that means it is occupying quite a bit of a memory, and the processes can go a bit slow, because you cannot make those agents down to make your speed of the processors or the applications that are running over there to be fast. Priority is to make the agents up and running every time, because if the agents are not running, Chef will simply not work, because it depends on the pull model. Whereas Ansible does not need any agents to be running on any of the servers, distributed servers. Every decision, all the decision will be taken from the master server where Ansible is hosted. Okay, therefore it knows what to deploy or what to configure, what to push, because it is based on the push model. I do not need agents. So agents are a very important thing, that if you can avoid that, your process becomes too streamlined, easy, hassle-free, and you do not need to take care that the agents are always need to be running. That is a one big advantage of not having agents on the Ansible clients. And another one is the security. See, in a pull model, when you have the agent is also pinging the server, the host server. The host server is also pinging. So the channel has to be both ways. So a channel is like this. The tunnel has to be cleared. Now, when you communicate to and fro between the server, that is, this is the client agent with the agent, and this is the server with Chef. So what will happen every time you have to keep these two channels open? Server is pinging the client for its availability. Client is also pinging the server for its availability. Otherwise, the communication will not happen between the agent and the server. So there is a risk. What is the risk? Risk of security, because you have to keep this channel always open. So there can always be some hacking. Whereas this one, with the Ansible, you do not need to keep the channel open. As and when it is on demand, when you say that I need to push something, configure something, then I will immediately connect and go. So connect and forget. You do not need to keep remembering your connection history. It is called serverless connection. So I do not need to maintain any state of the connection. Just for the purpose of getting something done, I will connect, and then when the purpose is served, I will forget it. This is a very secured model of connectivity, and that is done via SSH. You know, secured shell connectivity. That is one of the securest open SSH, open suite of connectivity. And it is one of the easiest form of communication between easiest, secured, plus simple. So what you want? You want both of them. It should be simple. I should not be involved into any complexity, as well as it should be secured. Are you getting me? So if both of these purposes serve, that is the best solution. So that solution is given by SSH, and Ansible uses this particular because Chef will have its own network protocol, third-party protocol, and that is not good, not preferred. This is universally accepted. This is the most common form of connectivity between the server and the clients. So why not use the most accepted form of connectivity and the easiest, simplest form of connectivity? So it doesn't need a special agent on the client side. No need, no agents. And by pushing modules, see, we are pushing the module. So Ansible is a push model. So pushing modules to the clients, I do not need any agent to be installed on the client side. The modules are then, once the modules are available on the local side, that means the modules are pushed from here to here in this India server. And once it is there, then you can locally execute. So the execution will become the execution of the local modules become faster execution because it is available locally. Whereas in Chef, you are actually executing it because it is pull. It has pulled that particular module over here. The processing will be done over here, and the result will be again deployed. So that's a time-taking process. This is not a very efficient way of doing. I'm not saying it is not fast. It is also fast. But if one of the elements fail in between, the entire process becomes a failure. So why should we go into that complexity? Because first of all, you have to pull the module, process the module, and then deploy the module again onto the server. So why to do when I can simply push that module and execute the module over locally? That is the best architecture. So the modules are executed. Let me clear this. So the modules are executed locally. That is very important on the client side, and the output is pushed back to the Ansible server. And this becomes very, very fast because there is no agent in between to do the processing. The server process, always remember, server processing is always faster. So the pushing of the module is pushed. Any module will be pushed. The configuration module will be pushed to the client. The client will process locally, which is also fast. Processing will, so pushing is fast. And then the result is pushed back to the server. There is no processing, just a FTP. So the FTP is again a very fast process. File transfer protocol. It uses a protocol to push the result back to the server. Okay. Just without any processing. There is no processing needed because your client will process and then your that particular thing will be configured over here. So only whether the result is okay. So okay is 200. 200 is the code for okay or success. Will be known, will be sent back to the server to just say that my processing has been done successfully. That's all. I do not need to process it again. Whatever the processing happens locally. Any question?
No.
Anyone?
No.
Oh, okay. So since it uses SSH, it can be very easily connect to the clients using SSH keys. That is a topic that we need to know how. You know the key pair that we have seen when we were using cloud AWS. That how a client can connect to the server through a key pair. Similar is the concept of SSH keys. We will install the keys on the server, and that key, if there is an authentication of that key, and so easily the client can connect over the key. It is very simple. If I get an opportunity, I will show you but that is in the next weekend. Okay, how a server, Ansible server connects to the client. I can display that before I display the demo on that particular thing. Simplifying though the whole process. So this whole process, because you are using a key pair, there is no complexity. Just use that key pair or the SSH key. I will show you. Client details like host names or IP address, that is whatever is needed for SSH connectivity will be there and stored in the files called inventory files. Now, this is a very important concept. Everything will be there in the inventory file. Inventory file is sort of a file that will be accessed. So there is some configuration over here that is called inventory file. So Ansible will first of all I will consult or read the inventory file and take all the inputs to connect over SSH, because there will be the IP address of the server to connect, okay, of the remote server to connect, the domain name and all those stuff, the host name. So then it will be connecting to the host, to the server host. That is, this is the client. Very simple. And there will be, so your inventory will have your key. So this server, because this inventory will be there on the main server where you have the Ansible. So this is the Ansible server, the master server. This is not the master, this is the slave or the host. Okay, to which it will connect, push. But all these inputs will be taken from the inventory file where it will know where it needs to connect, what is the IP address of that server to connect, and all those details. Everything will be done, and with the help of SSH, it will connect to over this. I think I will be able to show you, demonstrate on the next day. So once you know how to connect to a distributed or a separate client distributed somewhere in any part of the world, you have almost done 70% of Ansible. The rest 30% is how you play around with the configuration file called playbook. Like in Terraform, you have the .tf file for the configuration files, where you write the HCL or the shorts script of what you want to do, declarative way. Here also you declare what you want in a playbook. So once that connectivity has been established, then you read this playbook, execute this playbook to deploy the configuration over onto your connected host. Any question? So once you have created an inventory file and populated it, Ansible can use it. Ansible, of course, Ansible will read this file to get all the input environment or the input parameters for connecting to the host client. So Ansible is an open source configuration management tool. Open source, why? That is the big advantage. You do not have to buy a license to learn and use Ansible. You do not spend a single cent for learning and operating and using the configuration tool called Ansible. Used for configuration management, can solve a wide range or variety of automation challenges. Written by Michael Dehan. Like there are few names in the IT. One of them is Michael Dehan, giving this wonderful product called Ansible. Okay. Named after a fictional communicating device called the Ursula K. Le Guin in her novel Rokanan's World. Don't worry about all these things. So basically, that Ansible term has come from some communication device. And the most important part is Ansible is no longer part of the company called Ansible, but it has been migrated, or Red Hat has acquired in 2015 the entire product called Ansible. So Red Hat becomes the owner of Ansible. So if anyone asks you who is the owner of Ansible, you will say it is Red Hat. But again, in 2019, IBM has acquired Red Hat. So indirectly, IBM becomes the owner of Ansible. So if somebody asks you who is the owner of Ansible, you say IBM is the owner of Ansible. Prior to IBM, it was Red Hat who was the owner of Ansible. Sorry, there is no hash. Sorry, hyphen. Red Hat is one word. H will be capital. So now Red Hat's owner is IBM, as therefore Ansible's owner is also IBM. Is that fine? And in this particular year, I was with IBM from 2009. And during this period, there was a huge festival in IBM, because to acquire Red Hat was a sort of a victory. There were many competitors, and IBM emerged victorious to acquire Red Hat. There was a lot of celebration in IBM during that time. One of the pink years of my career in 2019. I was an IBM project manager during that period of time. So we celebrated a lot for this victory. Okay. Anyway, so IBM, with the acquiring of Red Hat, came into the world of cloud. So IBM Cloud was launched. It was there, the Blue Cloud, IBM Blue Cloud was, but it was not that much, attractive or feature loaded. But once Red Hat is the Linux company, this famous Linux company. So any company who is working on the cloud they must be having a master Linux server, Linux technology. And with acquiring of Red Hat, IBM became the Linux owner. And therefore the IBM cloud is now almost within the first five cloud. Okay. Any questions till this point? So can you understand why Ansible is so important? Why people are running after Ansible? Because ultimately IBM is the owner of Ansible. So you can say the pedigree of Ansible has greatly increased after IBM has taken over Red Hat and Red Hat had taken over Ansible. So it is a huge boost to this particular software, and therefore it is futuristic because it is under the giant company like IBM. It becomes futuristic. So if you learn Ansible, you are not going to regret because it is going to stay for future. So why Ansible? One of the most significant advantages of Ansible is that it is free to be used by everyone, being open source. It does not need any special system administrator skills to install and use Ansible because, as I told you, learning curve of Ansible is too less in comparison to any other configuration management tool like Chef. Chef and Puppet, there are and Salt. These are the competitors. But nowadays, you have no competitor. There is no competition at all. Chef was the nearest competitor. It is almost dead. Not dead, I will say, but it is quite lagging behind after IBM has taken over Ansible. Puppet and Salt, they are the competitors, but they are nowhere in the picture. They are lying in almost. So it is a 2020, and now we are in 2025. In the meantime, IBM has made Ansible a great configuration management tool, automation tool. So now this Chef is somewhere here. Okay, this is Ansible. Because of its simplicity, for its security, for its wide number of features, and official documentation to learn it is also very comprehensive. Its modularity, the modules, it uses modules regarding plugins. It uses plugins, modules, inventories, and playbooks that make Ansible the perfect companion to orchestrate large environments. So see, you are not talking of a very simple environment. You are not talking about 50 servers, which is also a huge number, but you are talking about around 500 servers you are managing all over the world. If it's a big company, like some big company. Okay. So to manage a large scale environment like this, you need a very stable uh, uh, an orchestration tool which can handle a large environment. Enterprise level of tool. Ansible is very lightweight and consistent. That's very important. I do not need a huge amount of space in my server to install Ansible. It doesn't take much time, and also it is very less in the number of the size of what it does. And it is very consistent, no constraints regarding. So in Chef, I know Chef, I have used Chef. I know that the consistency is one of the biggest problem in Chef. Every now and then the agents die. It is very because Chef to see there are servers, say there are so many servers. Each of these will have agents chef agents installed, and one of them will, every time there will be some heartbeat going on from the server. This is the server where the chef is installed. So it is sending the heartbeats to check every now and then. There is a polling system that whether this client is alive, client is alive. Now they think of 500 plus servers, and how some way or the other, because these are all over the network. So something can go wrong somewhere, and then it cannot communicate. So it is not very consistent. It is not very stable. Even for a small cluster of 5 clients, generally in my session, I use 5 clients and 1 server. Even in that environment of a cluster, this is a cluster. We have to build a cluster because they have to be talking to each other over a cluster. That is the biggest advantage of Ansible. There is no cluster mechanism. It is on demand. Whenever the Ansible master server wants to connect, it will connect. It does not need to keep the channels open for connectivity. Why unnecessary overload the system? So this cluster has to be every time maintained. It is costly affair as well. You must have a dedicated team to maintain. For 5 clients, for 1 server, client is a small cluster. You do not need to maintain any team. But as I said, if there are 500 clients and say 20 servers catering to the 500 clients, then there is a big cluster. You have to maintain it. So there has to be a dedicated team. So it becomes a costly affair, as well as now it is not consistent. Even after you have maintained a dedicated team, every now and then there will be customer complaints that the connectivity has been lost, or we are not being able to access the applications, something like that every time. And no constraints regarding the operating system. It can operate, Ansible can operate on any operating system. It is not restricted to Linux only. It can operate on Windows. It can operate on Mac, or you give any version of or any flavor of Linux. There are hundreds of flavors of Linux, any Linux. So it does not, it gets constrained over the operating system to be used, or basically the physical layer of the hardware. Absolutely insulated from all these constraints. It is also very secure due to its agentless capabilities. Yes, that makes it very secured. You are in absolute control of your connectivity and all the stuff, because you are running agentless capabilities with Ansible. And due to the use of Open SSH security features. So as I told you, Open SSH is one of the most reliable and secured connectivity software. Another advantage that encourages the adoption of Ansible in the industry is its smooth learning curve. Smooth. Determined by the comprehensive documentation and easy to learn structure and configuration. As I have told you, it is very, very simple to learn. My 5 sessions against 10 or 12 sessions of chef. And even that, after that also, it is very difficult for my students to understand chef after 10, 12 sessions. Whereas my students find it absolutely wonderful, and they learn completely one configuration management tool within 5 sessions. Sometimes if my batch is quite, I will not say intelligent, but they are very proactive, they are interactive as well. So I complete Ansible in 4 sessions. Any questions? No. So the architecture. You see, the architecture is very simple. It is very simple. The main Ansible automation engine lies on this is the server. This is the main server on which you have installed Ansible, correct? So with installation of Ansible, your inventory is installed, your APIs are installed, your modules are installed, your plugins are also installed. So these are the four integral part of Ansible. Just give me 1 minute. I will have one glass of water. Yes. So see, when I install Ansible, and installation of Ansible is one of the simplest things to do compared to Chef. At least 2 sessions I need to complete installation of Chef to make the cluster up and running. Okay. But in Ansible, I take not even 15 minutes. Not even 15 minutes to complete my Ansible installation. 15 minutes is too high. I'm saying between 5 to 10 minutes. My installation on Ansible is done. If possible, I will show you the installation and the connectivity on my next session. So you will appreciate that how fast your Ansible and how easy it is to install Ansible. So with the installation of Ansible, you have the inventory as a file, the host file, the APIs to connect to to make a API call to your host. So these are the host machines. These are the machines which are there in different parts of the world. Maybe this is in India, this is Japan, this is somewhere, Africa. Modules. Modules are very important integral part of Ansible. Ansible works entirely on the modules. So modules are codes developed by someone from the Ansible team. There are around 750 plus customized modules, inbuilt modules, system modules, you can say, already available once you install Ansible. And this modules are nothing but small programs or codes which will help you to do lots of configuration activity on the remote host. Let's say you want to copy file from your server to all of this host together, all of this host. So there is a copy module already inbuilt. So this copy module will help you. You do not need to write a code. The code is inbuilt as a module. You just use this module to copy a file to file transfer from server to client. So let's say this is one of the tasks, configuration task. You want to copy a configuration file from one server to the other server, and then you can execute that file over onto the local. That you can just use a copy module and your work is done. So that is already inbuilt within that more than 750 modules available once you install Ansible. Again, on top of that, suppose you have certain task which is not inbuilt as one of the modules, you can customize. You can create your own module. That is also very, very much possible. Customize your own module. So a particular task which is not actually frequently used by the others, so they do not appear in this particular. This is a very, very customized work in your company, maybe. Then you can create your own customized module, which you are going to use in this enterprise, otherwise not. If there are common tasks that you want to do, you can use it is already in the library. Just use it. How to use it, what to use it, all there are nice documentation. Very, very simple. You just copy paste from the documentation. Every of your task, whatever you need when you are working in an organization, suppose your project manager has told that, okay, Debashish, you use Ansible to do me this particular configuration. Okay, I will just go to the documentation and check and copy. Maybe a little bit of customization I will do on my own. That's all. My work is done. That's why DevOps is so popular, you know. Everything is available in the documentation. Even in Terraform, everything is there. I have not shown you how to get access of all those. Like we have done some module, some demo, and that code. I also didn't create that code. I just copied and pasted into my script into a TF file, and just here and there I customize. That's all. But the entire structure, what I have to write as as HCL is all available in the Terraform documentation. I just copy paste. Similarly, you will copy paste on the playbook, the modules that you need. I will show you. Then the plugins, you know, the plugins. Again, like in Terraform, you use the plugins to connect to your through the networking, you connect to your host and so on. So all these plugins for the particular configuration will be available, because there can be a lot of mixture of types of hardware that you are working on for configuration. So that you do not need to worry. You can use any of those plugins to be able to connect. Not only connect you on the particular type of server. So this can be a Linux server. This can be a Windows server. This can be a Mac server. And even on the Mac server, there can be lots of other types of configuration, softwares. So whatever it is, you will use plugins to do all those things. So that structure is you can connect over the Ansible server from the public or private cloud. Your database can also connect to your Ansible engine. Users can connect directly to your Ansible engine, or users may interact with your Ansible engine through the Ansible playbook. This is the playbook through which we are writing our configuration declarative script. Clear? So this playbook will do whatever I want to do, use the modules, use the plugins, whatever, and then use the inventory to connect to the host and configure it. So the simplified view, you are the master DevOps guy. You are the master. You are writing a playbook, Ansible YAML format. You know YAML, right? Once I have discussed what is YAML. Yet another markup language. So it is like the JSON format of writing the code. JSON is JavaScript object notation. It is a key value pair. Key value pair. So over the internet, you represent your data as your JSON data. So any transactions that are happening over the internet is like so say first underscore name. This is the key. Okay, then you say with a colon and then give the data. So this is the key. And then I say Debashish. This is the data. So this is called the value. So whenever you want to refer to this value, call this key. That's how it is referred, or that's how it is represented in a JSON format. JavaScript object notation. This is the key and value separated by a colon. So whenever you refer to first name, Debashish will be the value. And then you say last name. That is sort of a variable, the key. And then you say so whenever you call first name plus last name, it is Debashish Pal. And when you write in this YAML format, the JSON data, it becomes a playbook. You cannot write a JSON data without a YAML structure or a template. Anyway, that is some template. There is a few rules to write a template like YAML. It's very simple, very simple. You take it from me. The name is big, but actually it is very simple. And then with this playbook, you access the inventory because you wanted to connect to this hosts. So the parameters to connect to this hosts will be written in this inventory file. So Ansible playbook will access this inventory file, then call this the particular modules like copy, ping. There are so many modules I will show you. These modules will be called according to your usage, and then you use an SSH and Python. So one requirement, these are agentless. These are agentless clients. But what is one mandatory thing? Whether it is Windows or Mac or Linux, whether it is Windows or Mac or Linux, this is going to have Python. That is the prerequisite. And there is an option whenever you are creating or connecting to this, the first thing after you have connected with SSH, it will check for Python, whether it is Python is available over in these systems. And that is called gathering of information, gather. So first stage is to connect with SSH, then gather the information to say your ping plus pong, that is a response. You are pinging the system and a response goes back to the server saying that pong is a response success. If both are done correctly, that means you have Python on your system. If Python is not there, the gather will fail the pong. It will say Python not available. So generally what Linux vendors are doing, they are packing up Python with every of the installation. So operating system Linux will have, especially Ubuntu, has Python already inbuilt within the with the distribution. Are you getting me? So these two things should work. Ping, you have to successfully ping using SSH, and the pong will gather the information. And if the information says that your server or the host has Python, then the pong is successful. Any question? So this is the basic requirement. You need to have Python on each of these client machines, because Ansible here also, whenever I will install Ansible, I will show you next day that Python is inbuilt in my server because I am using Ubuntu. Ubuntu software or operating system comes automatically inbuilt with Python. I do not need to install Python separately. So if you have Ubuntu all over all these machines, And generally people will use, of course, the server has to be a Linux server. Even the clients, generally people are, or organizations are always deploying operating system Linux. Or can anybody tell me why Linux? Why not Windows or Mac? First of all, Linux is very stable, very stubborn, very flexible, and the most important part is, can anybody tell me, help me, which is one of the most important part for which the industry goes for any server having Linux operating system?
I think it's security. Is secure.
Security. Yes, fantastic. And one of the aspects of security is virus. Linux kernel is designed such a way that a virus cannot infect the kernel, whereas the virus can easily infect Mac, or Mac is a bit difficult than the Windows, but still Mac can be infected. But Linux, it is 100% foolproof. I'm not thinking of the not talking about the hacking or the cyber security. I'm talking about the virus. At least the virus infection will not happen. Cyber security is a different topic altogether. But your resources, unless you know DevOps, you should be finding DevSecOps very, I mean, it will be not very easy. I will say it will be not that difficult when you do not know DevOps. It will be a bit difficult to learn DevSecOps, which is part of cybersecurity. Because after all, whatever resources and configuration that you have done through DevOps are the things that you need to secure using the DevSecOps tools or processes. Okay. Any question? So fantastic. You said security, and security is one of the most important thing that why we consider having the clients all Linux clients. Linux has a wide variety of distribution. It is not only Ubuntu. It can be Ubuntu. It can be Red Hat. It can be SUSE. It can be CentOS. It can be Kali Linux. And there are lots of other varieties. It can be AWS Linux, proprietary, AWS Linux, and so many. So similarly, we have this inventory. So what happens is once you write your playbook, you will access your inventories. And with the help of the inventories, the inventories are nothing but a list of hosts where playbook tasks will be operated. So the playbook is actually a list of all the tasks. You are doing some activity, some configuration activity on those hosts. But before that, you need to connect. And how do you connect? All these configuration parameters, or not the configuration, the connectivity parameters are available in a file called inventory, which will list the host with its IP address or domain name. And all these things are available. So another is the playbook. The playbook is the configuration file in Ansible. This is sort of a configuration file, like in Terraform, you have the .tf files, Terraform files. Similarly, here you have the playbook files, where you write something in YAML format, in a JSON type of representation of the data, key value pair. So describes the tasks to be executed. So what is the function of a playbook? It will be having all the tasks described to be executed on the hosts. Written in a very simple language, playbooks are like instruction manuals. So like you are declaring what you want. Declaring what? And this what is the most important thing. What you want, what you desire. So that means you declare. You do not need to do modular programming. No need. That will be done by the imperative or procedural guys who are developers. Developers will think of how. You will think of what. So for what I need scripts, and these are Ansible scripts called playbook. Any question? You might be wondering, how do I write a playbook and all those stuff? But since our scope is limited, but still I will use one session for demonstration next weekend. Similarly, the modules. What will the modules do? When you write a playbook, you write the module within the playbook, and the modules will be accessing the module library, and the modules are like tools. Modules are like tools or small programs which can control system resources like services, packages, etc. As I told you, there are more than 750 core modules, more than enough. More than enough that you need. 750, can you imagine? 750 tasks or modules already inbuilt for you. You can use them. And also it will allow for you to customize your module yourself. If something is not available within the 750 plus core modules, then you can also have your own module incorporated and use. So the configuration and the host files. So whenever Ansible is installed, you will see there is the Ansible folder under the etc folder. etc is a universal folder in the when you learn Linux, you know what is an etc folder. Okay, so under that folder, Ansible folder will be created, and there is a file which will be installed called hosts. That is called inventory by default. Inventory default file. Now, this is generally I will not prefer to use the host files, which are the default inventory file, because I want to customize my file, and whenever you will name it something else and keep it in a particular folder of your project, then you need to give any name other than hosts, and then you manage or mention that what is your file name. There is another configuration file called installed already as Ansible CFG. So you will edit this file, edit that CFG file and mention what is your inventory file name and where it is located. That's all. So instead of looking by default into the host file, it will look into your, because Ansible, when the playbook is executed, the playbook will always consult. The first thing it will do, is to check the configuration available under the ansible.cfg, this CFG, and whenever it finds something mentioned as inventory as a parameter equal to some name, some customized name, okay, then it will never go and look into the host files as the inventory file by default, but then it will look into this particular file located in a particular folder with the mention of this particular thing. So once it knows, then it will go to the inventory file to understand the parameters to connect to the hosts and onwards. Is it clear? So these are called default system configuration and host files. Any question? Is anyone there?
Yes, sir. There.
Oh, thank you. Thank you very much. Sometimes I.
We're following, sir.
Thank you. Thank you.
Yeah.
So see, there is a structure. What it does, whenever it will read the playbook, first of all, it will not go to the inventories because it is not sure whether the inventory is the default inventory, the host files, or it is something else. So what will it do? It will go and check this part, ansible.cfg, available under the server, the Ansible server, under this particular folder. And there, if it does not find anything called inventory mentioned as a parameter, then it will go for, definitely it knows that that is the host file. So initially your Ansible CFG is almost empty. Though the file is existing, but only comment entries are, I will show you. But if you have to have some configurations available, customize it, then you put those statements inside the configuration CFG file. Then only it will not go and check the host files as your inventory file. Otherwise, it will be your host files. So playbooks, as I told you, is written in a YAML format. It is in a YAML format. Compared to the languages used in other configuration management tools such as Puppet, the syntax used in playbook is much easier to write. So Puppet or Chef, it's a bit complicated to write a configuration file. So that's what it is mentioning, Puppet and Chef. It is quite difficult, but here to write a playbook is much easier to write and comprehend because it is simple English like desirable statements or what you desire, or declarative statements, English like, very simple English like. I will show you. I don't know how much I can show you, but still you will be able to do it. In comparison with ad hoc commands, playbooks are used in, so ad hoc commands is like interactive commands from the prompt. From the prompt you write Ansible something. This is called a direct command or CLI command. Ad hoc commands. But ad hoc commands is interactive. For automation, you cannot write ad hoc commands. You have to write all these commands compiled in a file. And this file is called the playbook, where each of these instructions will be, say, instruction number 1, 2, 3. So it will come down to execute like this, top to down execution in this sequence, like in any programming file or code file. It will start from the first line, second instruction, third instruction, that way it will. So, but here it is very simple. It is written in a very simple declarative way. and you do not write ad hoc commands. Playbooks are used in complex scenarios because a playbook, say ad hoc commands can do one task, not even one task, one level of activity, done and forget. But here you need a series of activities to be done step by step. So you compile them into one big file or one file called playbook to handle a bit of complex scenarios because they offer increased flexibility. Playbooks use YAML format, so there is not much syntax needed, but indentation is must. This is very, very strict. You cannot disobey or violate the principles of indentation required in a YAML format. Must be respected. Ansible playbooks tend to be more of a configuration language. As I told you, it's a configuration language than a programming language. It is not a programming language like Java or C++ or Python. You need to learn them quite in details. Here, I do not need any language. That's why it is so simple, like Terraform, to learn it. Like the name is saying, a playbook is called as a collection of plays. So a collection of plays, one play is one task. Play is equivalent to saying, I am going to execute a task. So a combination of several plays is a playbook. Playbook is a combination or a collection of plays. Multiple plays, and you are compiling them into one playbook. Through a playbook, you can designate specific roles to some of the hosts and other roles to the other hosts. So in the same playbook, you can connect to different hosts and have different tasks. So all can be combined into one big playbook. That is where you come to now roles, because it's a dirty practice. It's not a preferred practice to club everything within one single playbook, because your playbook can grow a bit large file, and it will be complex and complicated to debug it if something goes wrong. So what do? You divide the playbook into, you can segregate out and make roles. Okay, that we will come. So you can designate specific roles to some of the hosts and other roles, because there will be different activities in different hosts. So why don't you break down the playbook into smaller roles, or the common things that will happen? So you can connect to different hosts, and every time you are connecting to the host, you call a particular role, because the tasks defined within the role may vary from server to server, from host to host. So let's say in one, this is host number 1, host number 2, 1 and 2. So this playbook on the principal server, on the main server, when executed, will install Java over here and install Python, let's say one web server over here. So you can think that these are two different tasks. Task 1. This is task 2. But there is a common portion. That you will connect to first this one. So there is a master playbook. Will call this role when you are connecting to this for installing Java. So there is a different role. And for this will be different because they are two different tasks. And think of 500 servers. So there is 100 servers will need Java to be installed, and the rest 400 servers will need what? One Apache server or any web server to be installed. So for this 100 servers, which role will you call? Which needs Java installation?
Role 1.
1, yes. Let's say I'm saying role 1. I'm giving it a particular name because I do not want web server to be installed over here. And for the rest 400 servers, which I connect from the master playbook, but I call that particular role, which is the role to install play web server with the role 2. So if I have this already a role created for Java installation and a role created for web server installation, and maybe another role, there can be hundreds of roles, but I do not need all of the roles to be compiled into one big playbook. Will that be not cumbersome? It is. If you write every task in one big playbook, it can go up to 1,000 lines. Though you are writing simple script, but to debug, if something goes wrong, to debug this 1,000 lines can be a nightmare. You do not know where it has gone wrong, what has gone wrong. You have to apply lots of debugging verbose techniques. And that is, if you are not, if you do not have any development background, it will be very difficult to even debug, even if you have the verbose facility. Still, it is difficult. So my advice is to divide. For each specific task, you define one role. One role. So the big configuration file becomes smaller modules, smaller roles, isn't it? That is quite good way of designing your entire thing. You do not need to every time see there out of the two tasks of so many tasks, you are sometimes you need only one task to be called. So why to call that one task out of the several tasks? You have to call this every time this particular big playbook. No, not needed. I will keep the common part in the master playbook, and then the specific task I will call that particular role. Isn't it good design? Your process becomes faster. It will be easier to debug and maintain. So many things are there has to be considered. You just do not blindly start writing configuration file like that. Initially, yes, fine. But as your experience or as your tenure in the project in your company grows year after year, you cannot keep on maintaining a single file. You have to split up the file. Otherwise, it can become very, very complex. Getting me? Any question? So I will not use so what I will do, I will I will use this 2 slides today and then we will conclude the session for that. And then the next session, the next weekend, I will explain the other 2 slides, other 2 or 3 slides. And whenever I come to this slide, sorry. So I will just explain the hands-on and then we will do the hands-on. Okay, so let me cover the where I was over here. So as I told you, Ansible playbook structure is like this. Ansible playbook is an organized unit of scripts, defines work for a server configuration written in YAML. So for any configuration task, you create a playbook. A playbook is combination of several plays. So it is a structure, is skeleton of this particular playbook. You start with a playbook. In the playbook, there can be one or multiple plays. Each play is a combination of tasks, one or multiple tasks. Each task is a combination of modules, notify, and handler. Notify handler is out of scope for us to understand at this stage, so we will skip that. But yes, tasks will call modules. Playbook can have number of plays. Play contains tasks. Tasks can call core or custom modules. Handler gets triggered for notify. Handler we will not. So this is the structure. You say which host you want to connect. So can anybody tell me when I say that I want a particular name of this host to be connected? So this is the key. This is the value. Can you see the structure? You start with a dash 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 to say there are multiple blocks in this YAML file. That is a structure. And you start with the first key as hosts in the playbook. You mention the host. Can anybody tell me where is this name and the configuration of this available? Which one it has to connect? And what is the IP address and what is the domain and all those stuff? How will this particular key help to look for this information? Where? When you execute the playbook? Anyone? Where will it look for the information of this particular? Because it needs to have the connection details. I would like to connect to this host.
Is it SSH?
SSH is the protocol to connect. That is the technology. Okay. But I'm saying this configuration. So I cannot just, this host one is just a name. But what are the details? What is the IP address of this host? Where it is available, whether it is in India or anything. So that IP address, that domain name. So how the DNS name? So how will it get? Where will it get this information from? We have discussed that the playbook will look for something, some file.
Inventories.
Yes. This is available in the inventory file. And what is the default inventory file? It is the host file. So if you have not mentioned in the Ansible.cfg, so this is the first file that it is always going, whenever you execute this Ansible playbook, it will first go and look into the Ansible configuration CFG file. If it does not have anything called inventory mentioned, inventory equal to something, it will definitely use the default host file. And in the host file, it will go and it will check for this name because you have mentioned this name. So what will it do? It will surely find something called host one, and the host one will have something of an IP address or maybe there is a group that I will show you in the next day. So having this IP address and all the connection parameters, it will try to connect to the host by the name host1 because it finds it. If it does not find this mentioned over here, then it will fail at this stage. It will fail. It will give you failure message. Unable to connect. Incorrect host name, something like that. The next one is sudo. Sudo is sort of another key. This is the key. This on the left hand side is always the key, and after the colon it is the value. It is a JSON type of data. What is it saying? Yes. Yes means I want a sudo's super user privilege. Okay, to able to configure. So I have a sudo privilege. Name. What is the name of this playbook? I have given it a name. Play1. It can be anything. It's up to you. So whenever you run this playbook, you will see play1 is getting executed. And within the play, like in the play, you have these tasks. So the clause is called, this is a keyword. You cannot have anything like task or a capital T task. It has to be small. And also it has to be tasks, not task. There can be sensitive. So you cannot change this. It cannot be host. It has to be hosts. It cannot be capital S sudo. It has to be small sudo. So all the keywords will be all small letters and the correct name. So the name of the task is execute command date. So this is the name of the task. It has nothing to do. But what is the command? What is the thing that it will do? It will display you the date. Date on that particular host. Name again, the second task. This is one task. This is the second task. Execute the script on the server. So it has connected to the host and there is a script. It is trying to execute that script with the command or the clause keyword called script. You are executing this test script.sh. So where is this to be found? In which server? It is available on the host1 server, which it has already connected. So it will go to the default home directory and it is expecting that this script will be there. If it is not finding it, then there is an error. If it finds it, it will execute. So some activity has happened on the local, on the host1. So coming to the next play, it is so simple. See, you have executed two tasks. One is to display the date on the system and another is to execute the shell script to do some activity. Now, coming to the next part of the play, this is play 1 and this is play 2. So in this, you are connecting to another different host 2. Where will the details will be found? It will be again found in the, yes, in the inventory file. It can be hosts or a particular inventory name. It is mentioned over here. And it will be successfully connecting it. If everything is fine, it will be play 2. You have given it a name. You say that I need a privilege to read, write, and whatever the sudo privilege. And then because I want to execute the tasks, first task is to execute the script on the server. So let's say in the host 2 also there is a script or a shell script that you want to execute. So this is called module. This is called module. You are calling this module. You do not need to program it. Just a module, and the module will do to execute this script available on the home directory. This command is another module. This is another module. Okay. And thereafter, after it has, so there is another task, task number 2. This is task number 2. This is the name of task number 1. And here there is another module called APT. This is another module. And with the help of the module, you are installing Nginx app server or web server, sorry, with the latest version. All these things we will learn in the next session. We will go through. So isn't it very simple that what you have done? You have executed a script on the server after connecting to host 2, and then you are installing Nginx web server just with the simple command or the simple module. You are calling this module from within the playbook APT. APT is the name of the module. If anyone has any concept of Ubuntu, Ubuntu has a package called APT. This is to install your, this is the package manager. If somebody knows Linux, you know this is a package manager. The package manager APT will install the software. Like in Windows, you have Chocolatey. Like in Mac, you have Homebrew. With the help of Homebrew, you can install any software. With the help of Chocolatey, you can install any software on Windows. Similarly, on Ubuntu Linux, you can install any software using APT. It's the package manager. So with the help of APT, you are installing Nginx with the latest version. Can you see how simple it is? Just a one-line statement. So you execute a command in host 1, execute a script in host 1. In the next task, next play, you execute a script in host 2, you install Nginx in host 2. So these are basically the 4 tasks that you have done. So many things you have done, but with a simple playbook. Isn't it interesting?
Very interesting, sir.
Yes. So all this configuration, there are lots of things. We do not have that scope, but anyway, when our intention is to give you our objective is to give you the overview such that whenever you start learning that tool in details, you will find it easier because you have the concept. You know what is what. You know what Terraform is, how it works. You know what Ansible is, how it works. Okay, so that is what I have already explained you. So today I will end the session over here. I know it's a Saturday evening or a morning or an afternoon in your place. So I will not bother you with too much of information. Let us take it in a relaxed manner, step by step. We will again continue the same topic with more of an hands-on with the next session. So I will conclude the session for today. I will stop sharing. Yes, thank you. I will stop the recording and I will request Shubhro also to stop the live recording, live session.
Thank you, sir.
Yes, thank you very much. So we can end the session. Thank you.
Okay, sir.
Thank
Yes,
you.
Sir,
Yeah.
sir, this, I went to do some study on modules in Terraform, where you have to call up the modules so many times when you want to provision resources in different environments. So it's similar to this Ansible, where you have to call up. You have a playbook. It accesses the inventory files for those the configurations of the host and all that. So I'm just seeing the as similarities there.
Right, exactly.
Yeah.
But Terraform modules is a bit different concept than
Yes, I know. Yeah.
Yes.
Ansible. Yes.
Than Ansible, yes.
Yeah,
Exactly.
Yes.
But more or less the structure or the concept is more or less the same. Yes, you are right.
Yeah. Yes. It's instead of you copy and pasting HCL code for almost a similar resources that you want to provision, you just have a module where you just call it so many times, and it makes it very easy and simple.
Easy and simple, and the most important part is reusability. You see, you can
Good reusability. Yes.
you
Yes,
can reuse them
it.
again and again
Yes.
as and when needed.
Yes, true.
So you do
Yes,
not have
true.
to recode them again and again.
Again, yes.
It is sort of a library file. It is there available in the library. You just pick up that book and read it. Sort of like that.
Yes, sir. Thank you so much, sir. We
No
are
problem.
grateful.
Thank you. Sure.
Thank you.
Thank you.